The American Astronomical Society is proud to launch the latest version of AAS WorldWide Telescope. Get ready for WWT 2022. AAS WorldWide Telescope isn't a physical telescope, but it is a tool for exploring the universe. WWT is a suite of software and data that combine to create stunning astronomical visualizations. You've been looking at visuals created by WWT using some of the new datasets that have been added in the WWT 2022 release. In fact, the new release more than doubles the size of WWT's built-in data holdings to more than 4,000 images. At the end of this video, I'll run down the highlights. While WWT started out as a standalone Windows application, it's evolved into a whole ecosystem of free and open source software, whose development is sponsored and overseen by the American Astronomical Society. The software runs on platforms ranging from mobile phones to state-of-the-art planetariums. This versatility helps explain why WWT is used by all kinds of people, from researchers to teachers, from enthusiasts to planetarium operators. And no matter what brings you to WWT, the new 2022 edition brings great new features that we think you'll love. Out of all of them, the new feature that I'm most excited to share with you is WWT's awesome new Jupyter Lab interface. It's a data visualization application, but not like anything you've seen before. It's designed from the ground up for the era of the science platform, with a modern user interface to match. Because it's an app and not just a widget, you can launch WWT with the click of a button and set up your screen to keep your code and data right next to each other. It only takes 3 lines of code to pull up an image, and you can do a lot without typing any code at all, like overlaying data from the Gaia EDR3 catalog, which WWT downloads on the fly through its new support for progressive HIPS datasets. We haven't just shoehorned an existing app into Jupyter Lab. We've built the app from the ground up, with the idea that most people's code and data are going to live in the cloud. We've also built the interface to intelligently blend interactive and programmatic control. For instance, once I've zoomed in on a view of interest, I can extract the catalog data from WWT right into my Python notebook. Because WWT is rooted in the sky, it's great for multi-wavelength work and for visualizing extended structure, like in this combination of observations from the Meerkat and Chandra observatories. Just as important as the new app interface is a powerful new feature added to the WWT 2022 rendering engine. Thanks to support from the NSF, WWT now lets you explore huge, and I mean huge, FITS images on the cloud. For instance, here we're loading up simulated full frames from the Rubin Observatory Desk project. Just looking at the data like this is really hard with traditional image viewers, and that's even if the data live on your own hard drive. Viewing huge images from across the internet raises even more challenges, but those are exactly the challenges that WWT has been solving for a decade. So even though each of these tracks is more than 3 gigapixels in size and lives in a server off in the cloud, you can zoom in and investigate down to individual pixels, and it's all smooth and responsive. Even better, the WWT research interface isn't actually tied to Jupyter Lab. It can run in any web browser window, and we've designed the experience to take full advantage of that. Any visualization that you create you can export with the interactivity to embed it in your personal website, or include it as an interactive figure in your next paper with the AAS journals, or add it as a figure in your next iPoster. So instead of sharing your beautiful mosaic as a distorted, downscaled, and blown out JPEG, you can share the actual data. Even if you're not working with raw astronomy data, WWT 2022 gives you great new tools for sharing images. If you're an astrophotographer or other image creator, and you've been dissatisfied with the gap between what you make and what people experience, the new WWT should be a breath of fresh air. To go along with the research app, we have a new WWT sharing app and a creator tool that makes it easy to get the links and HTML code you need to share WWT-based visualizations. Even more important, WWT 2022 comes with new tools to help you get your data into WWT's formats. A new command line tool that we call Toasty can process all sorts of input images. It's heavy-duty enough to work with gigabyte-sized data and a whole bunch of different input formats, but it's also smart enough to handle most inputs without forcing you to fiddle with a bunch of settings. For specialized circumstances, we've created a tool called the WWT Aligner, which can match up press release imagery to original FITS files and emit coordinate information in the AVM format. In most cases, the amazing astrometry.net service can figure out image coordinates without a reference, but if, say, you've got a very small field of view, the Aligner can come in handy. Work on the Aligner was generously sponsored by the Space Telescope Science Institute. To show off your imagery with a bit more pizzazz, WWT's guided tours are here to help. It's ridiculously easy to combine images with camera moves, overlays, and even music and audio tracks. And you can share tours just as easily as you can share standalone images, using our app and creator tool. If you educate or do public outreach, WWT's tours are a great way to teach astronomical concepts. The end results look great, and everything your students see is based on actual scientific data. And you don't have to start from scratch. WWT comes with an ample library of built-in tours. To get started, the WWT Ambassadors program at Harvard offers battle-tested lesson plans for evergreen topics like the phases of the moon. If you've already been teaching with WWT, the 2022 edition adds some new arrows to your educational quiver. Thanks to the Toasty Data tool, it's easy to get the freshest new images into a tried-and-true tour. And with a sharing app and creator, you can embed tours right in your online learning materials, if the tools support it. If you're in the planetarium business, we hope that these kinds of web-based features in WWT 2022 will help you stay connected with your audiences. As an example, you can post embeds in tours, or live stream out of the WWT Windows app like David Weigel of the US Space and Rocket Center is doing here. The Windows app is also what you should use when it's time for serious work in the dome. WWT 2022 includes a new stable release of the Windows application, adding in support for HIPS imagery and catalogs, as well as some sneak peek support for image-based distortion calibration and the latest Oculus VR goggles. We're also very excited to announce a cool collaboration between WWT and the Open Space Visualization software. Building on WWT's new scriptable web apps, the latest versions of OpenSpace can now embed WWT to overlay high-resolution imagery in OpenSpace's 3D views. Besides being a great way to take advantage of each project's strengths, this collaboration really showcases the power of the new programming interfaces that we've made available in WWT 2022. AAS WorldWide Telescope is not just a set of applications. It's a whole reusable toolkit for building custom astronomy visualizations, using either Python or TypeScript. Here are some clips from a couple of custom web apps built using WWT under the hood. WWT does a ton of the hard work for you. You don't need to have an army of developers to build something really cool. Last but not least, we mentioned that WWT 2022 more than doubles the size of our collection of built-in datasets. Let's take a look. WWT 2022 includes literally hundreds of new images from NSF's NOIR Lab, formerly known as NOAO, and the European Southern Observatory. It adds smaller collections from other famous observatories, including SOFIA and LOFAR. On the planetary side, WWT 2022 adds the Celine Kaguya terrain camera map of the Moon, with a resolution of 7 meters per pixel, new panoramas including a gigapixel view of Mars's Van Zeel Overlook from the Perseverance rover, and a map of the asteroid Bennu from OSIRIS-REx. New all-sky maps include 2 synthetic maps derived from catalogs, one based on Gaia DR2, and another based on the Deep Star Maps 2020 data created by NASA's Science Visualization Studio. WWT 2022's new HIPS support means that we add literally hundreds of new scientific datasets to the collection, including UNWISE, DR 1.1 of the SkyMapper Southern Sky Survey, the TESS 2-year Mosaic, and many more, including major catalogs too. The WWT team is incredibly grateful to all the scientists and engineers who not only produced these datasets, but made them publicly available as well. But there's no dataset like your own, so whether you're a professional or an amateur, a researcher or an educator, if you've got data, anything from your first astrophoto to a gigapixel mosaic, we hope that WWT 2022 gives you a really compelling new way to explore and share it. To get started, visit the WWT 2022 homepage at the URL on your screen. If you have any questions, the WWT team will be eager to help. From research to education to just sharing the wonder of the cosmos, we're incredibly excited to help you do something amazing with WWT 2022. The sky's the limit, literally. Finally, don't forget to sign up for the WWT newsletter and like and subscribe here on YouTube and other social media. You won't want to miss out on some of the great features we're planning to roll out this year. Thanks for watching.